Hello, my name is Alina Bogumill, and today I will be talking about source filter theory and the process of producing a sound, starting with the fundamental frequency and ending with formants. So for examples, I will be focusing on the vowel sound E, as in keep, and also on the consonant M, or the sound. So source filter theory was developed by Gunnar Fant, who was a Swedish scientist. His theory came about in 1960. So essentially, the source filter theory explains how the vocal tract filters glottal sounds, making it so that we hear speech in the way that we do. So there are three elements involved in the creation of a speech sound. These include glottal sound, vocal tract resonator, and the sound at the lips. The first element is the glottal sound. So this is where the fundamental frequency or the lowest frequency of a sound comes into play. So air leaves the larynx and has not yet reached the vocal tract where it will be filtered to create speech sounds as we hear them. This air flows through the glottis, causing the vocal folds to vibrate. If this sound was heard without this filtering process that takes place, it would resemble a buzzing sound. This element is known as the source function because the glottis is the source of the sound. So the second element is the vocal tract resonator. The vocal tract in humans is composed of the pharynx, larynx, nasal cavity, and oral cavity. So essentially, the vocal tract is a tube filled with air, and that makes it an acoustic resonator. So this tube is closed at the glottis and open at the lips. So in other words, it's closed at one end and open at the other end, making the vocal tract a quarter wave resonator. So in other words, with this type of resonator, the lowest resonant frequency's wavelength is 4 times the length of the resonator itself. Another thing to mention about the vocal tract is that it is considered to be a variable resonator. So this means that frequencies can change depending on the shape of the vocal tract, which can change. So these changes filter the sound so that the buzzing sound produced by the glottis is filtered into the sounds perceived as speaking. This element is known as the transfer function, which can also be referred to as the resonance curve. So there are 3 main elements that can be manipulated that cause this variation in the vocal tract resonator. These include the location of air constriction, the degree of air constriction, and also the length of the vocal tract. The third element is the sound that comes out of the lips. The glottal sound has been filtered by the vocal tract, and the fundamental frequencies amplitudes have been modified, reaching the formant, or the area of acoustic energy in resonant sound. So this element is also referred to as the output function. So for the E vowel sound to be produced, air is pushed from the diaphragm and the lungs. It travels through the pharynx into the larynx and through the glottis, where it causes the vocal folds to vibrate and then resonates through the oral cavity. So for this front high vowel, the tongue raises toward the palate, the pharyngeal cavity behind the tongue gets bigger, and the oral cavity in front of the tongue gets smaller. So the formant frequency F1 is low in this high vowel, and the formant frequency F2 is actually of higher value due to that shorter oral cavity. So for the M consonant, or the sound, to be produced, air is pushed from the diaphragm and the lungs. It travels through the pharynx into the larynx and then through the glottis, where it causes the vocal folds to vibrate. So this sound is bilabial, meaning that it is created with both the upper and the lower lips. So both lips curl in, sealing together. the soft palate drops, allowing air to pass through the nostrils. So this noise exiting the nostrils is referred to as a nasal murmur. And this nasal murmur is characterized by the presence of a nasal formant. When the velopharyngeal passageway opens up after the velum or the soft palate is lowered, the nasal cavity is attached to the rest of that vocal tract. So the formant frequency F1 is high, and the formant frequency F2 is low due to that longer oral cavity that is formed.